Welcome to the podcast. I'm Stan Farnsworth at NextFlex, and this series is Electronics at the Edge, where we dive into what is hybrid electronics, what are applications, who are key players. And for episode number one, our key player is Dr. Dan Gamota. Dan, good morning.
Morning, Stan. Thank you. I'm really excited to be here and help kick off this new series, Electronics at the Edge.
Tell us a little bit about your role at NextFlex.
So I joined about a year ago. I'm executive director, and I spent most of my time at in industry, both serving as executive at OEMs as well as at EMSs. And I was really intrigued when my former company became a founding member of NextFlex because we saw on the horizon the importance of hybrid electronics. And we kept on hearing from our customers that hybrid electronics was going to be critical for them in their roadmap to be able to stay ahead of their competition. And so about a year ago, the opportunity came my way, and I was really excited to be able to join the team and work with people like you and others as we try to build on the three most important things for hybrid electronics. One, strengthening the industrial base, expanding the number of hybrid electronics integration into products. And then the third one is ensuring that we have a strong workforce, basically to make sure that we continue to design products and manufacture them to our best.
Now, hybrid electronics is a concept and a phrase that has had a continual evolution over the years. Talk to us a little bit about the history of hybrid electronics and what it is today, and then maybe we'll stretch into where we think it's going. But let's start with that first.
Well, I truly believe hybrid electronics and this podcast series is about exploring innovations that are, to me, literally changing the future of electronics and manufacturing. I think it's doing it through the lens of collaboration, creativity, and impact. To me, hybrid electronics is truly, as you said, it's been evolving. It's, for the most part, electronics where you can be able to place electronics everywhere. And the one thing that I've noticed is that we need to reimagine. And so at the very beginning of hybrid electronics, I remember that people would say they're building products, and they're building products that will enable electronics to help us foster life and to help us ensure that the electronics are evolving similarly as our life is evolving. And so that there is this harmony between evolution of a human and evolution of electronics. For the most part, we've always imagined how electronics could be conforming to our lifestyle, how to get integrated into our world. And it wasn't just simply looking at a circuit board. It was looking at what is that circuit board together with the electronics, what kind of functionality do you ultimately achieve? And so in the very beginning, when I remember hybrid electronics, it was that people were upset about a display. The display was too small, display was too rigid. So we went into a innovation cycle that we sat with business development folks that were developing next generation communication products. And we sat there with them and listened to some of the requirements necessary for today's products, but also some of the aspirational goals that some of their consumers were asking for. And it turned out that there was demand for lightweight, ultra thin, flexible communication devices. And I use the word communication device because it wasn't only about a display and being visual. It was about verbal communication. It was visual communication, but not dynamic. It was just ensuring that people felt closer to their products. They felt that they were part of an experience and it had to be immersive. And so very early hybrid electronics was trying to create a wow factor for individuals. But as you know, creating a wow factor and actually delivering on the wow factor are two different things. And very quickly, we learned that there were limitations around the traditional electronics. The portfolio of microelectronics that were available to us constrained us in terms of the form, fit, and function. And so we started working with innovators and we started understanding what the limitations were of reducing the thickness of silicon to determine how silicon at some point goes through a transition of being rigid to flexible. We learned about what the benefits were of a rigid board, but then also understanding what were some of the constraints that it had and how those constraints would be broken down by going to a flexible board. We then spent time with people understanding what were the limitations of their existing products and how we could improve the interactivity with their products. And so I would say that very early on in hybrid electronics, it was very foundational, understanding what were the hopes of future products, but then also being very thoughtful in terms of understanding what the limitations were of the existing building blocks that we had accessible to ourselves, and then what were some of the needs and gaps that would have to be developed over the next 2 years to be able to deliver on these products.
So what were some of the key gaps that you found and experienced when you were looking at how traditional electronics might be able to build a better connection into consumers and the variety of use cases that we see?
I wouldn't just say naysayers, but there were some technologies that were very difficult to replace. Design rules were very well established. Manufacturing processes were established. People tended to be risk averse. And so initially, it was very much required for us to bring those individuals that were not interested in changing and have them become part of the community, have them provide insight and really be a collaborative environment. They tended to be very thoughtful in terms of providing what were the benefits of existing technologies. They also, upon thoughtful reflection, they started saying, well, if you could do this, that would be a benefit. And so it was really trying to bring together individuals that had established very well thought of technologies and capabilities and having them become partners in this journey of ours to try to bring forth a new technology, new capabilities that would allow designers more freedom in their product designs.
Yeah, I agree. In my experience, exactly the elements you mentioned. It's different form factors, use cases for which the traditional rigid board assemblies are not a great fit, either because of size or thickness in some capacity, or weight, or the particular function. And that really what's been developed over the last couple of decades, I think we can say now, is a new approach to different types of conductive materials, dielectric materials, processing to be able to reliably, consistently, repeatedly get the optimum performance for those new materials on a whole set of new substrates. So we're talking about shifting from traditional FR4 layered structures into flexible PET textiles. Glass is sometimes used now as a substrate, polycarbonate, different kinds of polymers. And what's been exciting to me is to see that through the leadership of folks like you, Dan, and others in the community, and then through receptiveness on the customer side, these applications are now in use. These materials are in use. I know that they're in automotive, they're in aerospace, they're in consumer electronics. What are some of the applications that jump out at you, Dan, as far as things that people might not really be aware of yet?
I think that in a lot of ways, what we've seen is hybrid electronics has been adopted by companies seeking to improve the performance and functionality offerings. In a lot of ways, you don't necessarily see those products per se because you're not opening a product and looking for specific elements of this portfolio of hybrid electronics. I think in a lot of ways, what's happened is that individuals have been looking for a solution that maybe the electronics had to be a certain thickness. There were limitations as to weight and the constraint associated with weight. And so what I'm noticing is that wearables, there's a significant premium placed on wearables that provide you a unique experience. That unique experience requires a certain functionality. It requires the ability to collect data. It needs to be able to display the data meaningfully on a display. It also needs to be able to communicate and collect and transmit. And so all of those key functional blocks are ones that you would find, for instance, in smart glasses. And so if you look at smart glasses today, there's been a significant premium placed on smart glasses that look more like your glasses. And how are you able to do that? Well, you're able to do that because hybrid electronics provides ultra miniature components. It allows you to use, instead of traditional thick, rigid substrates, you're able to use thin, flexible substrates or maybe a composite of flexible and rigid. All of these are critical to be able to provide the appropriate functionality in a very small, tight space. So smart glasses is definitely one. Another one that we're seeing is that there's a certain amount of anxiety associated with how much operation you can get after charging, maybe a drone or charging your car. Those ultimately you're asking for in your car, you're asking for more functionality, you're asking for a greater experience, you're asking for more human machine interfaces. All of that requires power. All of that also requires electronics. You need to balance those two. And so hybrid electronics is a great way to offer more functionality without actually taking on the weight burden. And so you're seeing a significant amount of hybrid electronics being designed in cars where they don't want to reduce the fuel efficiency, but they want to be able to give greater functionality. And so they're able to do that because of the lightweight and low profile nature of hybrid electronics. Similarly, drones or even delivery, whether it's a delivery drone or it's a drone that's being used for industrial applications, those drones, they want to have additional functionality integrated into the drone, maybe perhaps doing sensing, acoustic sensing, video recording, maybe chemical or biological sensing. All of those have a certain power budget requirement. And also to put them and to integrate them into a system, you need to take into account the weight requirements. To do that, it's more efficient to use hybrid electronics, as well as by using hybrid electronics, you don't have that weight burden, which ultimately allows you to continue having the same operation cycle of 1 hour or 2 hours per charge. So anything that really has a concern in terms of demands operating for a particular amount of time or for a particular distance, hybrid electronics is definitely one of the options designers today are using. The third one is healthcare. I think that what we saw during the last 5 years is that people are becoming much more comfortable with having on-body types of systems. Those on-body systems are able to collect data. That data then can be transmitted to your healthcare provider, and then the healthcare provider can review the information and, as appropriate, have you either change perhaps your medicine or perhaps have you come in for a checkup. I think this is really something that has evolved into more of a standard. I think originally people were much more comfortable seeing a person physically, but now I think this virtual acceptance of your healthcare provider together with unique hybrid electronics that have enabled a portfolio of different types of products that can do physiological monitoring on the body. So all three of those very much dependent on the benefits associated with hybrid electronics: lightweight, low profile, and increased functionality in a smaller footprint.
Yeah, and to me, the hybrid in that comes from the combination of these new materials, new processing, combined with elements of traditional electronics. So solder is still used, still using surface mount, through hole. These are all well established. SMT's been in acceptance now for I think around 40 years. So what these new materials and processes are allowing is really an extension of the tried and true capabilities of the more traditional electronics, but allowing them to be used, as you said, in use cases where form factor, weight, some element of function would otherwise be outside of the normal capabilities of that. So the hybrid electronics is really the intersection of the new electronics and materials technologies, still keeping elements of the traditional electronics materials and technologies. And so to me, that's a moving zone, because particularly we see, Dan, just about every day that there are new materials, there are new processes, there are new use cases. What are your thoughts about the evolution and progression of what hybrid electronics means? Maybe just briefly touching on the technology elements that are continuing to evolve, but then also on the use cases and how individuals are becoming more accepting of using these in their use cases.
So what I've seen is that we have kind of gone full circle. And what I've seen is that initially when hybrid electronics were becoming mainstream in terms of the innovation engine associated with disrupting traditional electronics, I felt that a fundamental appreciation of, as you said, materials, processes, and then products. And I remember early on people chasing large flexible displays, people chasing less, RFID at less than 1 cent. But I think in the end, we truly were trying to develop a platform technology, and that platform technology enabled certain applications. The applications themselves, I think, would ultimately be challenged by market dynamics, and that would decide their success or not. I think today we've kind of gone back to that. If I look through my lens and if I think about how hybrid electronics is presented, as you know, it seems that today hybrid electronics is again in a position where we're developing a platform, but the platform is not per se a particular material or a particular process. I believe the platform is a multifunctional, uh, high density module where the module has all of the functionality. It has the sensing, the actuation, the computing, the communications and power. And then that module is being integrated into a variety of applications. It could be put into a terrestrial vehicle. It could be put into a space vehicle. It could be put into a water vehicle. And so I think the future is quite bright, because now what you have is a module that has all of this functionality that truly makes it into an edge device. It could be a standalone edge device, and that edge device now is integrated into a mobile device. It could be integrated into a wearable. It could be integrated into an autonomous vehicle. I think that's what the future holds for hybrid electronics, is that it becomes more of a building block for a larger system that now provides some functionality. So it's really taking what I think is surfaces and structures that perhaps in the past did not have functionality. Now you're making them smarter because you're able to integrate electronics into that structure, or you're able to integrate electronics under that surface. And then it's also taking some of the existing products and making them smarter, because now you have a module with this uber functionality that provides computation and communications in a very small volume.
I think that's one of the things that's exciting to me about this technology space is that uh, there once we decouple the very specific material uh, parameter space of traditional rigid electronics and start to hybridize that with these additional additive flexible materials from the printed hybrid elements, then that really pulls away the guardrails and the applications. And so now we find, I think, from an adoption perspective, sure, that hybrid electronics can often be a drop-in augmentation for existing products or existing functional definitions, but really more often the hybrid electronics elements really allow new product concepts, new use cases, putting sensors, functionality, communications in places and on products and surfaces that wouldn't normally be able to accommodate that. And in my experience working with design and product and manufacturing engineers that have come to us over the years at NextFlex and in my previous lives around applying these technologies to solve their problems. There's a couple things that happen. One is we certainly appreciate those individuals coming to learn more about the technologies when they don't have that deep of a background, but they're interested and curious and maybe have some strong use case, demand signal that requires that. But as they learn about the technologies and they see it happening in front of them, and so we always encourage people to come see us at our NextFlex facility in San Jose. But as they see these in person, they really start to get an appreciation of what the capabilities are of the performance of these materials and processes. But then they also can extrapolate and go back to their product definition and their projects and understand how these technologies can impact their products and their projects, and in many cases enable different design decisions that have to be made. I know that you've seen that in your customer experiences, Dan. How would you say that customers have, in general, received these kinds of technologies once they get an understanding of their capabilities?
That's a great question. And I will highlight what I think is the most natural growth of an individual from being a creative person to being an innovator. I was able to participate in early on before joining NextFlex. I was able to participate in Flex Factor. And Flex Factor is one of the foundational programs that NextFlex established. And I was always amazed that within a few months, you had an individual that was not familiar with electronics. They usually were not familiar with manufacturing, and they were not familiar with entrepreneurship or product design or identifying a gap or a need. And what I would notice is that given a little bit of knowledge on hybrid electronics and the benefits, you would be able to enable these young students. You would give them something that would take their creative ideas and convert them into innovative prototypes. And I think that is something that we need to replicate, because a person that is given conditions, boundary conditions, they tend to not be accepting of trying new materials or trying designs or processes. In this particular case, these individuals didn't know what the constraints were. They didn't know what standards were. They didn't know what best practices were around traditional microelectronics. And so I felt that the innovations that these students participating in Flex Factor were the most novel, creative, and I think quite compelling. And I believe that if they took them to market, they would have done quite successful, because I think that's where you have individuals that are not constrained by a historical perspective. And I think that kind of translates to what I saw in industry. Whether on the OEM side, product design, where you had to convince a product designer to try something a little bit different. Unfortunately, if they were trying something different and they were up against a compressed product launch, they typically didn't want to take on that risk. And so it was a difficult amount of time spent with them to try to convince them and to reassure them that taking on hybrid electronics was actually going to be a benefit to them. It would allow them to differentiate their product. It would also potentially become the next great revenue stream. And so I believe that is the biggest factor to not easily adopting hybrid electronics. And I think that in the commercial world, there are definitely companies that if they take the time, if they are truly collaborating with you, it's open, there's mutual respect, they appreciate all of the risks associated with the supply chain. They understand the risks associated on the design side, the manufacturing. If you're open with them and provide them that very deep appreciation of the different risks, they will adopt it. They will be very thoughtful in terms of how they launch the product, and ultimately they will become your greatest advocate to continue to use hybrid electronics. But I do believe that that's the difference is individuals in Flex Factor, they're not constrained by what is standard practices. They're not constrained by what is legacy. But in the commercial world, you tend to be risk averse and you do bound yourself. So I think truly to be able to benefit from hybrid electronics, you have to take away your in terms of what you're trying to achieve and what are you really willing to take on in terms of risk.
So how does NextFlex help people go through that process? What are some engagement mechanisms that we have to be able to bring that awareness, to take them through the learning on the technologies, and then help them carry that back internally into their teams?
Well, first and foremost, NextFlex has a very solid structure on how we identify gaps and needs. We have individuals on the team that are very well versed in how do you bring together individuals in an environment where they can be open and sharing gaps and needs. We have work groups that continually ask the hard questions. These work groups are very foundational to us. These technical work groups span different topics. The topics may be foundational in terms of a material or a type of process, or they could be more towards aligned to a application in a particular industry. These work groups bring together members from industry, academia, and government. It gives you three different lenses by which you're able to identify gaps and needs, and then in a consensus-based environment, you're able to prioritize. Is a very strong and powerful foundation for us because that leads to then NextFlex being able to we identify topics for our project calls. These project call topics are aligned with the gaps and needs identified by the work groups. The solicitation is asking our community internally at NextFlex as well as outside to be able to propose potential solutions. These solutions are then reviewed, and if they do receive the highest scoring, we try to bring them under contract to help us, the community, identify a solution. During the actual workshops that we have, we also are able to educate and take the information that is being gathered as well as information that's generated and have in a session with representatives from technology as well as business. Individuals are able to hear firsthand of what is the present state of the art, as well as what are some of the gaps that are being addressed. So I think that there are several mechanisms, but I think it always starts with making sure that you've done a industry analysis to determine what the situation is, collectively bring together individuals so you have a very broad aperture in terms of what's necessary, and then very quickly make sure that you're able to prioritize because you obviously want to make sure that you're setting up the individual people that are going to submit for success. And then ultimately, once you do have success, you want to be able to share that information with the community. So it's really identifying problems, identifying solutions and teams that can provide those solutions. And then the third one is allowing the community of hybrid electronics practitioners to understand how their toolkit is expanding and how the different tools, what is the state of maturity.
I think that's really a key element is that the NextFlex community, in addition to the capabilities that we have in-house through our equipment and our subject matter experts, is that we're also a center point for a large community of other subject matter experts and manufacturers, materials experts, and that includes universities all the way through to large product companies. I would encourage anyone that's interested in going to our website to see the members that we have in that community. But if you're a design engineer or a manufacturing engineer and have specific questions about the technology, I would encourage you just to contact us directly. We can put an engagement in place, just answer your questions, first of all, but then also we can invite you to come see us, come see the equipment, get a hands-on, in-depth understanding of what these technologies are. We can sit down and talk about the impact quite specifically on programs of interest for you. And if we're not able to answer questions, then we can certainly get you connected into our membership base, encouraging you to join our membership base, first of all, but then also to be able to uh, communicate inside that network, I think would be helpful. Dan, we really appreciate your time today. I know you're a busy guy.
All right. Well, thank you very much. I think that this has been great. I really appreciate having the opportunity to be part of this podcast. I truly believe that hybrid electronics is going to be a game changer for everything from defense to healthcare to consumer products. I think the most important thing that I would like to leave is that, as you said, it's a community, it's collaborative, and NextFlex is here and its members are helping individuals succeed in taking their ideas from a concept on a paper to a physical product that they can hold in their hand. And so, as you said, in the NextFlex community, you have materials suppliers, you have equipment suppliers, we have nodes that provide guidance to individuals in regional locations. We also have members that have tooling, special tooling that can be used, or materials that can be used to ensure that you have the appropriate functionality. And then, as you said, having a hub here in San Jose is quite special because it's a facility that allows people that don't have access per se to the engineers, the subject matter experts, or the equipment sets. They can come here and visit us in San Jose and try to build prototypes. And I'm quite happy with that. And that's something that's very unique about our institute, and something that I think that people respect. And if anything, I think that's what differentiates us from many of the other institutes, is that we have a very strong community. And we also give individuals that are interested in practicing hybrid electronics an opportunity to come and use the equipment sets to be able to take their ideas into a physical product.
I agree completely. And if you have any questions, contact Dan or myself or any of our team at NextFlex. And until next time, this has been Electronics at the Edge.